Let's jump right into it. By the very nature of its components, water used in industrial equipment invariably requires some form of chemical treatment. The minerals and elements naturally present in water are constantly interacting with the metallic and thermal components of the infrastructure. There is simply no operational scenario where raw water can be used without direct, often costly, consequences.
Industrial facilities absolutely have to intervene chemically because running untreated water inevitably compromises both the integrity and the efficiency of the equipment. Without that intervention, scale formation quickly blocks flow and severely reduces heat transfer. So, the real question isn't whether to treat the water, but exactly how it needs to be treated. For years, keeping equipment scale-free meant navigating this incredibly complex chemical process. The foundation of this conventional scheme is a liquid acid, which you need to strip away the existing scale. But naturally, acid damages metal. So to protect the infrastructure, you have to introduce a whole chain of extra products, neutralizers and corrosion inhibitors. Then, to stop the detached scale from causing blockages, you add a sludge dispersant. After that, a chelate goes in to prevent new scale from forming, and finally, a biocide to manage biological risks. It turns into this endless cycle of chemical compensation.
So think about this for a second. What kind of operational infrastructure is actually demanded to sustain that conventional multi-product juggling act day after day? Well, the traditional system demands intense 24/7 monitoring. It relies heavily on complex dosing controllers, constant on-site personnel, and perfectly calibrated sensors just to mitigate the ever-present leak risks. Now, in stark contrast, we have IQAGREEN. This is a single, solid, alkaline multifunctional product that gets placed directly into the equipment itself. You're basically substituting a massive, hazardous chemical room with incredibly compact, solid technology. Let's look at Section 2, molecular action, specifically the scale removal mechanism. If we're eliminating corrosive liquid acid, how exactly does a solid technology remove tightly bound calcium carbonate scale? It's all about physical alteration rather than acid corrosion. First, the active components penetrate directly between those bound minerals. Second, hydration kicks in, causing the compound to physically swell and increase in volume. Third, this expansion completely destroys the structural rigidity. The hard deposit becomes highly porous. Finally, it softens up and just naturally detaches as a sludge. But this detached sludge poses a huge risk if it manages to regroup. This is where electrostatic repulsion becomes absolutely critical. Electrostatic repulsion is a state achieved when the sludge dispersant gives every single particle the exact same surface charge. Because they have the same charge, they chemically repel one another, completely preventing redeposition. That saturated sludge isn't easily flushed out during your scheduled maintenance. But what about the unseen threats? How are dissolved scale-forming ions neutralized before they even get the chance to react and build new deposits? The solution here is the chelate. A chelate is a highly specific compound that hunts down and surrounds calcium and magnesium ions in the water. It physically traps them right in the center of a stable structure. The result? The ion completely loses its capacity to react, and if it can't react, it can't form scale. The problem is literally neutralized right at the source. Alongside this sequestering action, we also get passivation. Passivation happens when a specialized filming compound creates a continuous, highly compact protective layer right over the metal. This high-affinity film acts like a shield, chemically repelling water, dissolved gases, and corrosive ions. It physically blocks them from ever touching the metal and triggering oxidation. And here is the real game changer. Because this entire process occurs within an alkaline medium, the metal is intrinsically protected from corrosion. Unlike those old conventional schemes where acid aggressively attacks your infrastructure, forcing you to constantly pump in inhibitors, the alkaline nature of this solid formulation ensures the metal is never damaged in the first place. Corrosion simply cannot develop in this environment. Let's zoom back out to the real world for a moment. What is the physical footprint and the everyday safety profile of bringing this solid technology onto the facility floor? The operational results mark a complete ground-up transformation. Using a single solid product placed directly into your equipment means absolutely zero dosing pumps are required. You need zero containment dikes for chemical spills, and all those complex installations are totally eliminated. For your personnel, it is 100% safe. We're talking no acid splash hazards and zero toxic gas emissions. It's an entire system built on absolute safety and simplicity. So to pull all of this together, here are the 3 key takeaways you need to remember. First, this technology completely replaces dangerous, heavily monitored liquid systems with just a single solid alkaline product. Second, it eliminates scale incredibly efficiently without a drop of acid, using targeted molecular hydration to soften it, electrostatic dispersion to keep it separated, and chelance to trap the minerals. And third, it guarantees absolute infrastructure safety thanks to that alkaline medium and true metal passivation. Which really leaves us with one provocative thought. If a single solid product can perform the work of an entire hazardous chemical room and do it with vastly greater safety, why on earth does the industry still cling to the messy, dangerous methods of the past?